Welcome. In this tutorial, we will do the fundamentals of integrals, all of it. So that will be for all this lesson. Yeah, even if this lesson is divided on more than 1 week, we will just do all of it in this tutorial. Okay, so let's start here. FE exam problem typical. You will see it will tell you, for example, find the area under the curve. And to find the area, basically, that would be the area between your first curve and your second curve. So here we have our first curve, which is this guy here. And where is our second curve? We don't have a second curve, so our second curve is here. It's basically like this one. So it's just like f2 of x is equal to 0. So for any x value, y is equal to 0. So basically, this guy is equal to 0, which give us like the area would be the area under this curve, yeah, from here to here. Good. Sorry, because our second function is 0, yeah, and that's basically the definition of this. Like the definition of an integral is the area under the curve. Remember, the definition of derivative is the rate of a change, and the definition of integral is the rate under the curve. So how can I find the area or like evaluate this integral? Basically, I want to evaluate it from A to B. Okay, so like from A to B, that's from 10 to 12. Yeah, that's like my A, and that is my B. So I will have something that looks like this. Area or this integral is equal to A, like 10 to 12. That's my A, that's my B. And the integration of x squared plus 4 dx, yeah? So this is equal to what? So this is equal to, remember like how to do this? That's x to the power of 3, you add 1 here, and then you divide by this guy here. So you divide by 3, okay? So you add 1 here and you divide by 3. Here you add, this is x to the power 0, so you add 1 here, so that would be 4x to the power 1, and then you divide by 1. So basically it's 4x. Yeah? Okay, and we want to evaluate this from 10 to to where? To 12, yeah? So basically that is how you can do this. And then like we can simplify this a little bit. So like to simplify this, let's just take maybe, let's take x and 3 as like a common factor, yeah? So here that would be x over 3, yeah? And what we will get here, that would be like x squared, yes, plus 12. Do you agree? And that's evaluated from 10 to this. Yeah, did I do something correct? Yeah. Yeah, because, yeah, that's correct. And then what can we do? Then we evaluate this from 10 to 12. So that would be what? That would be 12 over 3, 12 square plus 12, yeah, minus x like 10 over 3 times like 10 square plus 12. Basically, like I'm evaluating this term. So I got something that looks like this, yeah? So I can simplify this maybe a little bit. So this is here plus this, that's what? So that is like 12 times 12 like times 13. I'm just doing some simple algebra here. And then here, this is 100, 100 plus 12, this is 112 times 10, this is 120. And I can take this 3 as a common factor divided by 3. Yeah. So you can do this with your calculator, or you can do it manually. So like, how can we do this manually? So you can take some common factor. So like, for example, you can say this is like 4 times 3, and this is like 4 times 3. And this is, what is this guy here? So you can, I mean, you do it anyway, you can just use a calculator. So this is like if you divided this by 4, for example, like what you'll get, you get 280. 280 you can still divide it by 4. What do you get? Like you get 70. So 16 times 70. So that could be like 16 times 70, for example. Yeah, will give you like this guy, and then you can take this guy and this guy and this guy and this guy as common factor. So that would be like 16 times, this is 3 times 3, 9 times 13 minus, yeah, 70 over 3. That will give me what? So 9 times 30, that is what? That is 117. I think so, yeah. 117 minus 70. This is times 16 here. Times 16 over 3. That would be what? That would be 47. So 16 times 47 divided by 3. So that would be what? So what is 16 times 47? So 16 times 47, that is equal to, if you want to do this, I mean, you can just use a calculator. That would be like 470 plus the 235, yeah. Yeah, so this is times 10 plus, I think, yeah, plus 40, yeah, plus 47. I think so. Yeah, over 3. So if you added this together, what you'll get? So you add like this guy and this guy, that will give you 605. And 605 plus 47, that is 600, and so that is 653 over 3. Something like this, yeah. If I did this correctly, let's check the answer. We have the answer here. Oh, sorry. I think I have 652. Because let's see, like, yeah, 600. Yeah, because this guy, yeah, 652 times 3. Okay. I mean, so you got like something that looks like this. I mean, you can just use your calculator to do these things. Okay. So I got like 652 over 3, which is exactly what I got here. Okay, let's do another one. then this problem, I'm not telling you the area under the curve, but I'm telling you the find the average value. So I'm asking for this average value from here to here, not the area under the curve, but like this average value from like here to here. Sorry, like this average value from here to here. Okay. And this has a formula, so we can just like use the formula. Yeah. So that's again B is 12, A is 10, and the integration from A 10. What is this guy here? 10 to 12. And what do I have here? I integrate this guy plus 4 dx. And if I did this, I think I did it already here, so I don't need to repeat this again. So let's just see what I got here. So when I did this integration, what I got is this number here. Because remember, I mean, we can do it again, doesn't hurt. So I will get like 1 over, because it's the same function as above, so that is like 1 over 2. And then the integration of this guy would be over 3 plus 4x, and this is evaluated from 10 to, and I already know, like if I evaluated this guy, I will get something that looks like this. Yeah. So if I evaluated this guy, I will get like 1 over 2 times 652 over 3. 6, 5, oh, sorry, 652 over 3. 652 over 3. So that would be 320. That's like the 300. That's 26 over 3. So that's basically the answers that I got here. Ooh, I got a different answer. Let me check this. Maybe I did a mistake here. This is 1 over 2. So 600 divided by 2, that's 300. 300 plus 26, that's 326 over 3. I got the same number here. I got 652. Oh, did I do something? Oh, sorry. I have a mistake here. That should be 752. So I got like, this is 7052 because like if you added this number here, so like if you added like these two numbers here, that will give you like 705, and then 705 plus 47, so that will give you 752, yeah, over 3. 752 over 3. So here I have like 752 over 3. So this is like 700, that is like, would give me 350 plus 26. Yeah, and that would be equal to 376 over 3. You can just use your calculator, it might be easy. 376 over 3, yeah. Okay, so I got like 376 over 3, and then you got something like this. Okay, let's do more practice here. So I'm giving you all this and I'm telling you integrate this. Let's just integrate it term by term, yeah? I mean, so like you can say like this is like A, like you can say this is like B, and then you add it all together, yeah? Okay, so let's just integrate it term by term. So let's say like integration of A, like the first term, that would be 3x square dx. Yeah. And this one, we know this one is not difficult. So how to do this one? You add 1 here. So that would be x to the power of 3. Then you divide by 3 times 3. Yeah. Plus constant. I will ignore the constant. So I'm not going to write down these constants because once we do like this guy, this guy, this guy, this guy, this guy, we can add the constant at that because constant is a constant. Yeah. So it really doesn't matter. So I'll just ignore. So I'll just say like x to the power of 3. Yeah. Let's do the second part. So the second part is the integration of 1 over 4 x squared dx. So we know that this is a constant, so I can take this guy out, 1 over 4. And then I could just express this guy as x to the power minus 2 dx. Yeah. Then then I have here 1 over 4. How do I integrate this guy? You add 1 here, so I have like x minus 1 because minus negative 2 plus 1, that's negative 1, and then you divide by negative 1. Yeah. So if you did this, then what you will get negative 1 over 4, and then you'll get negative 1 over 4x because x to the power of minus 1, remember, x minus 1 is equal to 1 over x. That's from algebra, yeah. And that's the same that I did here. So that's also from algebra, like 1 over x to the power 2. That is okay. Okay, so I can do something that looks like this, yeah. For this guy, let's do that. And then of course there's plus c here. I will not write it down, yeah, but you know that there, like the integration of 5x dx. Well, this guy has a rule here. Yeah, I just follow the rule. So that would be, this is the rule. So that would be 5x divided by a, which is 1 in that case, ln 5. Ln k is 5, ln 5. Plus c, yeah? I mean, okay, I can write it down. I'll just ignore it. Okay. So for this guy, that's basically what you got, yeah? Let's do the other one, like this guy here, number 4. Number 4, that would be integration of ln 3x dx. This one also has a rule, yeah? So the rule is x ln ax, so 3x minus 1, and plus the constant. I will just ignore it, the constant, yeah? So there is a rule for this one here. This is a rule. Okay, let's do this guy here. So integration of e, that is, I mean, 2x over 3x dx. That would be, I can take the 2 as a common factor, so that's like 2 times. And this guy also has a rule, yeah? So this guy here has a rule here, yeah? So that's 2 times. And what is the rule here? So that is e over 3x, and then k, which is 3, x minus 1, and that is divided by k, this is a k, square, so 3 square, yeah? So what would I get here? And then plus constant, of course, but I will just ignore it, so I get like 2 over 9 e to the power 3x minus 1, yeah? That's basically what I got. Do I have one more? Yeah, I have like the last guy here. The integration of cosine 3x dx. That one has a rule also. I can just follow the rule. So let me just do this rule. So that is 1 over 3 and then sine 3x plus the constant. Okay. So basically like the integration of uh, this guy, like the I here, would be equal to IA plus B plus C plus D plus E plus F plus the constant. Okay, so did I do this correct? Yeah, I think so. So yeah, like you see here, you just got this correct, this looks correct, plus the constant. Okay. I mean, easy stuff. How are we doing in time? I mean, this tutorial can take as long as they take. I mean, it's not important because they are optional to watch. Okay, so you can just go slowly. Okay, let's do the second part. Was about integration operation. Uh, and we learned several integration operation, if you remember, like integration with a constant, separation of term, integration by recognition, and integration by parts. So let's just do the separation of term. I mean, this is already things that we did before, but let's just practice more. Okay, so here, when I see this, like the main things that you need to learn here, you look at this power, yeah? So like this power and this power here. So this is to the power of 1, yeah, and this is to the power of 1. So as long as this guy is smaller than this guy, so this is or equal, so here, then I can do separation of term and I can use long division. So long division, if you remember this from your algebra, it's like division, yeah. So what do I want to divide? Like I want to divide what do I want to divide? I want to divide like this guy, yeah, by which? By this guy. Well, so what I want here, I just want to get rid of, of I want to get rid of this term, yeah. So that's basically what I want to do. I want to get rid of this term. So how to get rid of this term? If I just subtract it, if I just subtracted this guy, yeah, from this guy, I will just get rid of this term. So that is basically like this minus this equation. So if I did this minus this equation, I'll get 0 here, yeah, and then I will get this 2 minus negative 2, so that would be plus 4. Okay, so this means that the remainder is 4. Remember, like how you do division, and basically this means that I will get something that would look like this. I will get like, yeah, I'll get 1 here, yeah, because, and I will get 4 divided by 3x minus 2, yeah. Because remember, like if you multiplied this again here, like you multiplied, let me show you. Like if you multiplied 3x minus 2 plus 4 divided by 3x minus 2, that will give you 3x minus plus 2 over 3x minus 2. Yeah, I'll get back here. So basically, I just want to separate it, then make it like something that looks like this. Let me delete this. Okay, so now what do we do? So we just need to integrate this guy. So here, now this is something that I can integrate. So I want to integrate this guy. Make it, what do I want to integrate? Like integrate the x. Yeah, this is equal to what? So I want to integrate this dx. So this guy is easy. So the first guy is easy. So that would be like x plus the integration of, I can take the 4 out as a common factor of 1 over 3x minus 2 dx. Yeah. Does this look like, when you see something like this, just always remember something like this, because here, like if my f of x, for example, let's say is equal to 3x minus 2, what is my derivative of this function? That is 3, yeah? So this is not exactly 3, this is 1. So, but this is not a problem, because what I can do a trick. I can put like a 3 here and divide everything by 3. Yeah, that's just a trick, because this guy can cancel with this guy. Yeah, and then I got a 1 here. So when you see something like this 1 over something, just do this trick. Say, okay, I have this function, this is my f of x, and then the derivative of this guy is this guy here. Yeah, so that's the derivative of this guy. So what I can do, I can just put the 3 here, but in order to put the 3 here, I need to put another 3 here so that they can cancel out. Yeah. So now I have this guy here, so I can use this rule here. The function and its derivative. So this is the function and this is its derivative here. Yeah. See here? That's the function and its derivative. Okay, so I can do, I can integrate this guy. So that would give me here this guy plus 4 over 3 len. That's my f of x, so that's 3x minus 2. Yeah, because that's, remember, that's like your f of x is equal to 3x minus 2, and then your, this is equal to 3. Yeah, plus constant. Okay. So this is basically like integration by part, and this is something you can easily find in the FE exam. So I think I got these problems from FE exam books. Okay, so let's do one more, like, so that I got something similar. Yeah, here I got like 4 over 3, 3x minus 2 len something. So yeah, I got something similar here. Okay, let's do this one. This is also separation of term, but not with long division, with something else. So find, so what is I here? So what we can do here for this guy, we can just expand the term, the numerator. So that would be equal to 3x squared plus 3. Oops. Here, 3x squared plus 3 over x, yeah? And dx, yeah? So that's equal to what? So that is equal to 4x to the power of 4 plus, I multiply. So just to review your algebra, I know. So like you multiply this guy by this guy, then you multiply this guy by this guy, then you multiply this guy by this guy, then you multiply this guy by this guy. Okay, that's how you do it. Okay, so that's 4x plus So this guy times 3. So that would be 6x to the power 2. Then 3 times 2x squared. So that's like again 6 to the power 2. And then 3 times 3, that is 9. And all this over x. Don't forget like this guy. So I can do some simplification here. So that is equal to what? That is equal to 4x to the power 4 over x, plus I can add this guy with this guy. So that is 12x squared over x plus 9 over x dx. Yeah. So now this is something that I can do. Yeah, because, sorry, I have a typo here. It's x. Yeah. So what do I have here? So I have here 4x to the power 3 plus 12x plus 9 over x dx. Yeah, that's equal to what? So I integrate this. So remember, you add 1 here, and then you divide by 4. So that would be 4. 3 plus 1, that's 4 divided by 4. Plus you add 1 here, and then you divide by, so 12x to the power of 1. So 1 plus 1, that's 2, and then you divide by 2. Plus, remember this guy has a special case. This is a special case, so the integration of 1 over x, that is equal to ln x plus constant. Yeah. So that's a special case, so that would be 9 ln x, and then plus some constant. So this can go away with this can go away with this. So my final answer will be like x to the power 4 plus 6x squared plus 9 ln x plus the constant. I do something correct here. Let's check. See the answer. Yeah, looks similar. Yeah, so if I did this correct in both times, then the answer would be here like this. Okay, let's do one more lesson, which is the integration by part. And if you remember the integration by part, you assume that you have like two functions. So this is just practice. So this is basically a practice like regular integration, but it has one part where you need to use integration by part. So this will be just like our regular thing, except when you come to this guy here, you will need actually to use your integration by part. Yeah, because here we have like two functions. We have x and we have sine of x that are multiplied together. Okay, so this is just a good practice for what we did before. So let's just integrate. Let's do it also like part by part as we did before. Just more practice. Yeah, so I will just call this IOA. That's the integration of like this guy dx. That is something simple, like that would be 3 divided by 3, and then that would be, and plus constant. I mean, I can write it down, doesn't hurt. And then the integration of the second part. So here, in, 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 in this second part, I have the integration of x divided by x square plus 1. I mean, does this ring a bell? Does this look like something similar? Again, I told you, when you see something like this, you say, oh, I didn't take this, or that does not, I don't know what is this. No, this should ring a bell because this is a function and this is something like its derivative. So I can say like my function, my f of x is like 2, is like x squared plus 1. What is the derivative of this function? So the derivative of this function is like 2x. Well, I don't have 2x here, I have x, but it doesn't matter. Does it really matter? Because one thing I can do, a trick, is that I can say put 2 here and put 2 here. So like this 2. So now I have a function. This is like f of x. And I have the derivative of this function. And if I have a function and its derivative, let me delete this. If I have a function and its derivative, I have a rule for this. Yeah, that's a rule. So that would be 1 over 2 ln of my function. So that's x squared plus 1. Yeah. And then there's a constant here. Let me just ignore these constants. I will put it at the end. Okay. That's my function. And 1 over 2. Yeah. So that's like a trick. This one I have a rule for it. So A, C. So I have a rule for this guy. I can take the 6 as a constant. So here's 6 e to the power 2x dx. And then what's the rule for this guy? The rule is here. Okay, so that shouldn't be difficult. So that should be like e to the power 2x times a, which is 2, yeah, times ln k, ln e, and ln e is equal to 1, yeah. So, and don't forget, like a common mistake when you do this problem is that you will forget the 6 here. Don't forget the 6. Okay, so that would be equal to, and then there is a constant. I will just ignore the constant for now. So this will go away with this guy. Ln e is equal to 1. So I will get 3 e to the power 3 2x e to the power 2x. So this is all like easy. We did this before. Okay, where is the new part? Or is it? Where is the new part, like the integration by part? Okay, the new part is this guy. I mean, I don't have any rule for this guy, and I don't know what to do with it. Well, what to do with it when you see something like this, then you just do the integration by part. And remember, in the integration by part, you split you have two function, yeah. So you have two function. You can like you have two function. So you can take like one function, you can make it is equal to u, and the second function, or like this, you make it equal to your dv. And usually, remember, I told you there was a rule like which one to make it like your u and your dv. And if you follow like the sequence of a function, you will know that usually in that case, if you check this slide, remember, let me show you this slide here. I can bring it. Like how to choose your u and dv. If you remember something that looks like this. Let me put this down here. Like, so this is like the integration by part. You have your u and like your dv, and where is ux and dv. So basically, how to choose your u and dv. So you just follow this guy. So algebraic function precedes this trigonometric function. So this means like my u should be like the x squared. It should precedes this, and my dv would be this sine function. Yeah. So basically, that is like if that's how to do this. So let's just apply this here. So I will say like my u function that would be equal to x, and my dv function that would be equal to sine x dx. Yeah, just following this sequence here. Okay, and then that is basically you just follow, you just arrange it in this sequence. So you say like this equal to like my integration of like u dv, just like your u and just like your dv, is equal to uv minus the integration of v du plus constant. Okay, so let's just, so u, so when you got something like this, remember, let me just put it here, let me delete this. So you need to find like this guy, you need to find this guy, and you need to do this. So remember like how you did this. So like you say like here, that is like your u, and that is your delta v sine x dx. Okay, then what you do, you like you differentiate, you take the derivative of this side, and you take the over dx. Yeah, you take the derivative of this side, and here you integrate like this guy and you integrate this guy. So if I integrated this, I'll get like a v. If I integrated the sine, I will get if I integrated this guy, because here I want to get my du, so basically you take the derivative of both sides, and here I want to find v, so I just like integrate both sides. So if I integrated dv, I'll get a v, and if I integrated this guy here, I like the integration of sine x, if you remember, that is negative cosine x. Okay, so now I have my u, I have my du, I have my what's this? I have my dv, and I have my v. Okay, so now I can just easily substitute here. So my u is equal to x, and my v is equal to negative cosine cosine x. Negative v, which is negative v, which is negative cosine x, and this is, I have a du, and du, that is cosine x, that is du is dx. Yeah, cosine x dx. So how to do this one? So that would be negative x cosine x, and here that would be positive, and the integration of cosine x, if you remember from the table, that's sine x. So that is sine x. So basically, and then plus should be a constant here. Okay, or I will just ignore the constant here. So what is this integration? So the integration would be like the integration of a plus b plus c plus d plus this constant. Yeah. So negative x cosine x, and then I have here sine x. So let's see if we did this correctly or not. So let's go here. So let's see this guy here. So I have ha half len x squared plus 1. Yeah, I got this one. I got like the first one, like this guy here, x to the power of 3, which is here. I got this guy here. I have like 3 x to the power 2, yeah, which is, make this a little bit bigger, which is this guy here, yeah. And then finally, I have negative cosine x plus sine x, which is this guy here. It's my fourth term and plus a constant. Okay. So that was a good practice. Here, this is an FE exam problem, which is integration by part also. So here I have this guy here. Remember, this is the rule. I'm just putting it for you. So we need to make one function is equal to x, and the other function would be like your dv, yeah, because that's the rule here, yeah, like u and dv. So one function is u and the other function is dv. So again, this follows the same rule. So like u will be x squared and your dv will be 2x dx. Yeah, that is basically like how you do it. And then what you need to do, you need to find like du. So like du, that would be equal to 2x. You take the derivative of this side and you take the derivative of that. You need to find v. So you integrate this side, and then if you integrated ex, that would be e to the power x. That's the integration of this guy. Okay, and now we just put our rule. We have our rule here already. So our rule is the integration of uh, this guy, u dv, which is equal to u is x squared, dv is 2x dx. Yeah, that's dv, that's u. The integration of this guy is equal to u times v. So this is my u times v. This is my v. So that's equal to x squared e to the power x minus the integration of v, which is this guy, e to the power x, times du, which is 2x. Sorry, this is should be dx here, yeah, because this is remember, like I forgot to put a dx here. There should be a dx here because du over dx is equal to 2x, yeah. Du over, like this is my u, du over dx, that would be equal to 2x, yeah. So this is like my u is equal to x. Here, let me write it down. U is equal to x squared du over dx, that's equal to 2x. Therefore, like du is equal to 2x dx. Don't forget the dx here. Okay, 2x dx. Okay. So we have something that looks like this. And can we integrate this guy? Yes, we can integrate this guy because this guy actually Actually, no, we cannot integrate this guy because this guy does not follow this rule. But so what should we do? Well, what to do is just whatever you did here, just repeat it again. Yeah. So we can just like integrate this guy by parts again. So the integrate. So here I can just like integrate this by parts again. So here I will say my u is equal to like 2x. Yeah. And my dv is equal to e to the power x dx. See like what I'm doing here? Now my du is equal to 2, okay? Because that's my function, yeah? So d 2dx, okay? My du is equal to 2dx because remember, like my u is equal to 2x du over dx is equal to 2, then du is equal to 2dx, okay? And then what do I do here? And then for this guy, I just integrate this guy. So v is equal to the integration of this guy is again the same. And then I just like substitute, yeah? So if I did this, so the substitution here again is you use this rule. So if I say like 2, the integration of x dx, that is equal to what? That's u times v. So this is u times v. So that is equal to x e to the power x negative the integration of v, which is time du. So that would be v 2 to the power x times du to dx. Now, this is something that I can do because now I will know here this guy is 2x dx minus 2 to the power e to the power x because 2 times this is give me this plus constant, okay? So now I have this guy here. So let's go back here. So now I substitute, like this guy will just go here. So my integration here will be x squared e to the power x, x squared e to the power x x squared e to the power x, yeah, it'll be, you just see here is minus negative this guy. So negative this e to the power x, negative e to the power x, yeah. Negative this guy, so that would be equal to what? That would be x squared e to the power x minus 2x e to the power x plus 2e to the power x plus constant. So I can take e to the power x as a common factor. So I can take e to the power x as common factor. That will leave me with x squared minus 2x plus 2 plus constant. Yeah. Basically, that would be the solution to this guy. Yeah. So let's see if we did this guy correctly. So let's see, here's a solution. Oh, this guy here. Yeah, we got the same answer. Yeah, we did this correctly. Okay, it's a little bit tedious, but it's a little bit tedious, but that's okay. I mean, you can easily like get. Do I have one more practice problem here? I think there was one more. No, no, I think that's like the only two practice problems that I have here. Okay, let's do one more problem, which is the last problem in this lesson. Again, this lesson is over 2 weeks or more than 1 week, but it just has one tutorial for both of them. Okay, so here this is the higher order integration, and here I'm asking you a rectangular plate lies in a region of, this is in the x and this is in the y. The density of the plate varies according to this function. So I have like a density function. Find the total mass of the plate. So I want to find the total mass of the plate, and this plate, it varies. So this plate varies basically like on two interval. Like, so the first interval from 0 to 4, and then the second interval from 0 to 3. Yeah, so that's like my A, that is my B, here that is my A, that is my B. Yeah. And this is with respect to X, and this is with respect to my Y. Yep. And this is my function here. Okay. So let's solve it. So I will say, I will integrate this from 0 to 4. Yeah. And I will integrate, have a second integration from 0 to 3. And that is like delta x, or let me not do it this way. It might be easier. Or no, that's let me first integrate with respect to, like, make the inner integral with respect to x, and then the outer integral with respect to y. So remember, like, this has to do with the x, and this has to do with y. I think that would be easier to do it. I mean, doesn't matter. So here 2x plus y, yeah. Then I will integrate with respect to dx over this interval, and then I will integrate with respect to dy over this interval. Okay. So I will start by solving the inner integral, yeah, and then I will solve this like outer integral. Okay, if that makes sense. Okay, so let's just solve the inner integral. So 0 for 2x plus y dx. That's, so that's the integral inner. Yeah, that's equal to what? So that would be 2x plus x squared divided by 2. And what is this? This is a constant, yeah? Plus xy, because that's like a constant. So similar to 2, y here will be treated as a constant. Okay? So I'll get
xy, or if you want just yx. So see, similar here, like 2 is a constant, y is a constant, okay? You want to see it similarly. Uh, and this will be evaluated from 0 to 4, yeah? So if I evaluated this from 0 to 4, so all these terms will go away. So basically I'm evaluating it with respect to 4. So that is like 2 times 4 plus 4 squared divided by 2 plus 4y. Yeah. So like how can I simplify this? So if I simplify this guy here will be 16 divided by 2, that is 8, and then plus 8, I get 16 plus 4y. So that is equal to 16 plus 4y. That's equal to what? That is equal to 4 plus y plus 4. Okay, so I got 4 plus y equal to 4. That's the inner integral. Then solve the outer integral. So the outer integral will be the integration of, I can take the 4 out here, of y plus 4 from 0 to 3 with respect to dy. Yeah, something that looks like this. That's equal to what? So that is equal to y would be y square divided by 2. And again, like the common mistake here is that you will forget this 4. Yeah, that's a common mistake. Plus 4y. And I evaluate this from 0 to 3. Again, for 0, I don't need to evaluate, but basically I'll just evaluate it. And this would be equal to what? That would be equal to 4 times what is y? So that is 3 to the power of 2 divided by 2. Yeah. Plus 4 times 3. Yeah. Okay, so I got something that looks like this. And then I can evaluate this, so that would be 9. That would be 4 over 2 times, that's like 9 plus, what's this guy here? That would be 12, like 24. Yeah, because I can take this 2 out as a common factor. So that would be 2 times 9 plus 24, that's what? So that is 33. Yeah. So that will be equal to 66. Yeah, so that's the final answer is 66. So basically, if I integrated like the integration of this guy is equal to 66 and whatever kilogram or whatever, yeah, find like the mass of the plate. So that would be whatever this mass is, the unit is. Yeah, so I got a similar answer here. Yeah, 66. Okay. Okay, so I think that's all for this lesson. Yeah, and yeah, see you in the next video.